In the previous video, I taught you how to find all 18 trig values, these 9, plus the 9 reciprocal trig functions like cosecant, secant, and cotangent. We can find all 18 trig values by knowing only 3. So you have to memorize these 3 values, and I taught you how to find all of the rest. Let's move on from there and talk a little bit more about the unit circle. Alright, so for this video I'm going to assume that you can generate a chart like this in about 30 seconds. Now, the unit circle is just a circle that has a radius of 1. So here's my circle. I'm going to go ahead and put the y-axis and the x-axis like this. The radius is 1. So just keep that in mind. So here's a radius, and I know that's going to be 1. Now, here's really the most important thing you need to know about the unit circle. If you take any point on this unit circle, of course it's going to have an x-coordinate and a y-coordinate. But look, the x-coordinate is going to always be cosine of this angle. Okay, this is theta. So the x value is always cosine of the angle, and the y value is always sine of the angle. Alright, you just have to memorize that and know that. The x value is cosine and the y value is sine for whatever this angle is. So let's use that fact to answer some questions. Alright, so look at this first example. We're supposed to find the xy coordinates of this point right here on the unit circle. So we need to find x and we need to find y. So look, we're given the angle. So they just wrote it here next to the line, but this 4 pi over 3 means that the angle measured from the positive x-axis is 4 pi over 3. Now, a moment ago I just told you that the x value is always going to be the cosine of the angle, and the y value is always going to be the sine of the angle. So all we need to do is find what is the cosine of 4 pi over 3 and what is the sine of 4 pi over 3. Well, we had this whole chart that we learned to make in 30 seconds. But wait a minute, this chart only tells us the sine, cosine, and tangent of these 3 angles, pi over 4, pi over 6, and pi over 3. I don't see 4 pi over 3 on the list. Well, you know what? That is okay, because what really matters is something called the reference angle. The reference angle is the angle that is made with the x-axis. Okay, so this blue line is the terminal side of the angle. But the terminal side forms a smaller angle called a reference angle right here. How big is this reference angle? Well, it's going to turn out to be pi over 3. And here's 2 ways that you're going to know that. Anytime you see a 3 in the denominator, that's going to be the reference angle. So 4 pi over 3, I know that the reference angle is pi over 3. If it was 5 pi over 3, the reference angle would be pi over 3. But here's another way to think about it. I'm going to put it over here. I think it will be easier to just have a naked unit circle without the x and y axis for a minute. So I'm hoping that you already know that half of a circle is pi radians. Okay, so if this is the center, if I were to rotate from here to here, that would be pi. Okay? Now, what about pi over 3? Think about pi over 3. Well, pi over 3 is 1/3 of pi. So if I took pi and I divided it up into 3 pieces, that would look like this. Okay, now this would be pi over 3 because that's 1/3 of pi. And then this would be 2 pi over 3 because it's 2 of these. And right here, this would be 3 pi over 3 because 1 pi over 3, 2 pi over 3, 3 pi over 3. And of course, that's the same thing as simply pi. But I could keep going all the way around the unit circle. Right here would be 4 pi over 3, and this would be 5 pi over 3, and this would be 6 pi over 3, which of course is the same thing as 2 pi. Okay, so this is 4 pi over 3. This is the angle that we are looking at. But thinking of it this way, it's now easy to see why the reference angle right here is actually pi over 3, because all of these little pizza slices they're each pi over 3s. 1 pi over 3, 2 pi over 3, every slice is pi over 3. And this is simply one of those slices, so the reference angle is pi over 3. Okay, so coming back to this, you see the cosine of any angle is going to be the same thing as the cosine of the reference angle, except for one small detail. Maybe it has to be negative. That's the only thing that we have to worry about. So what is the cosine of pi over 3? Well, we've memorized that. The cosine of pi over 3 is 1/2. It's right there on our handy dandy chart. So because the cosine of the reference angle is 1/2, that means the cosine of the original angle is also 1/2, or maybe it's negative 1/2. That's the only thing we have to worry about. Does it need a negative sign? Well, okay, think about it. This is the x value. Look what quadrant we're in. Is an x value going to be positive or negative in this quadrant? Hopefully you can see that the x value has to be negative here in quadrant 3 because it's to the left of the y-axis, and all the x values are negative over here. So that's why the answer is going to be negative 1/2 for the x value. Okay, similarly for the y value, the sine of this angle is going to be the same thing as the sine of the reference angle, except it might need a negative sign. So what's the sine of pi over 3? Well, we've memorized that that is radical 3 over 2. Okay, you can use your little chart cheat sheet for now if you need to, but memorize this. Alright, so that means that the sine of 4 pi over 3 is also radical 3 over 2, except for maybe it needs to be negative. Well, again, we're here in quadrant 3. This is a y value. Will y values be positive or negative in this quadrant? Well, y values are negative in quadrant 3 because we are below the x-axis, so all the y values will be negative down here. Okay, so the x-coordinate is negative 1/2, and the y-coordinate is negative radical 3 over 2. Let's take a look at the next example. Consider all angles whose reference angle is 45 degrees, with terminal sides not in quadrant 1, because that one's already drawn. So reference angle of 45 degrees means we're talking about a terminal side that makes 45 degrees with the x-axis. So this terminal side right here would have a reference angle of 45 degrees. We could put another one right here. Remember, a reference angle is always measured against the x-axis. So there's going to be a reference angle above and below the x-axis. And we can put one more over here. And this would be the 45 degrees. Okay? Now, look, the cosine of all of these angles will be the same. And we've actually memorized that this is going to be 1 over radical 2. They're all going to have a cosine of 1 over radical 2, except some of them are positive and some of them are negative. So of course, here in the first quadrant, the x values are positive. All right, this is a positive 1 over radical 2. So look, just remember, cosine is an x value. Okay, this is really the key. Cosine is an x value. So look at these 2 points. Are the x values going to be the same? No. The y values are the same because they're at the same height, but this one is positive and this one's negative. So this is not going to be the answer. Okay, what about this one? Does this point have the same x value as the original point? No. All right, this is positive, but this x value is negative. So that's not going to be the answer. What about this one? Okay, does this point have the same x value as this point? Well, look, see how they're one right above the other? Yeah, both of these are equal to positive 1 over radical 2. Even if you didn't know that it was 1 over radical 2, you would still know that these will have the same x value. Okay, so this is quadrant 4. So that's why the answer here is quadrant 4. Okay, let's see. Let me erase some of this for the next question. Now, angles that share the same sine value. So as soon as you see that we're talking about sine, just remember that sine is the y value. Sine is a y value. So now we're asking ourselves, are the y values the same? Okay, does this point and this point have the same y value? Yes, these have the same y value. They're both at the same height. So quadrant 2 is going to be good. Okay, let's look at the other ones. Will this point have the same y value? No. The original point is up, this one's down. Those will be different y values. Okay, what about this one? Will these have the same y value? No. This is high, this is low. This is positive, this is negative. So it's only going to be quadrant 2. That's why the answer to this one is quadrant 2. Okay, now last one, tangent. Okay, the angles that share the same tangent as tangent of 45. Well, that is just slightly trickier. Remember that tangent is sine over cosine. So since sine is y and cosine is x, that means tangent is y over x. Okay, so let's think about whether tangent is positive or negative. So we have y over x. Well, that's in the first quadrant, the y value is positive and the x value is also positive. You know what, maybe I'll just do it off to the side. So we have a positive over a positive. Okay, so what's that? Of course, that's going to be a positive. So tangent is positive in the first quadrant. Okay, now what about in the second quadrant? Now, if we consider y over x, the y value is positive because we're up. The x value is negative because we're to the left. So we have a positive divided by a negative. That is a big old negative. So tangent is negative in this quadrant. Okay, what about in the third quadrant? All right, again, y over x. In this quadrant, the y value is negative because it's down, and the x value is negative because it's to the left. So we have a negative divided by a negative. What is that? Well, that's going to be a positive. A negative divided by a negative is positive. So tangent is positive in the third quadrant. What about the fourth quadrant? Y over x. In this quadrant, the y value is negative because it's down. The x value is positive because it's to the right. A negative divided by a positive is a negative. So tangent is positive in the first and third quadrants, and it is negative in the second and fourth quadrants. But the question was, where will the tangent be the same as the original, which was the first quadrant? Well, since tangent is positive in the first quadrant and it's also positive in the third quadrant, then the third quadrant is the one where it is the same. So that's why the answer to this third question is going to be quadrant 3.